So my name is Kasia Bourret. As Francesco already explained, I am coordinating a project which is a combination. It's investigating two directives: the INSPIRE directive and the information and the multimodal travel information system directive. My background is not geographic systems, not INSPIRE, but my background is, in the transportation domain, is public transport and data modeling in public transport. So you will hear some approaches related to data modeling today. As regards the policy background, so as already said, last year we had a new directive published, which number is 2017/1926, but this directive is often mentioned as Priority Action A. So the objectives of this directive is to define, first of all, to establish national access points to information. So every country has to have an access point to data. Several countries may also be brought together and have a common access point. Anyway, the idea is to publish data. Public transport mainly, but also you will see other types of data. This directive not only says how the data through the access points should be published, but also how this data within the different countries are going to be exchanged, and in view of the distributed journey planning, which is crucial to access transportation means. So a range of technical specifications is recommended for data publications through the national access points, so NAP. For the road transport, this directive links to another directive, which is called Priority Action B, which concerns road data, and is recommending the so-called DATEX 2 standard for the exchange and publication of road data. So I cite here how this is formulated in the directive. For other transport modes, one of the following standards and technical specifications should be used. NETEX. This is for public transport in general. This comprises road transport, but also some information on the air transport and rail transport. Then TAP TSI specifications, which concern rail, heavy rail, data and data exchanges, but also technical documents elaborated by IATA, which, as you all know, concern the air transport. And then for the spatial network, the requirements defined in Article 7 of INSPIRE have to be used. So this, in particular for public transport, this gives the following picture. These circles are the national access point in different countries. So there are some of them in this picture. And within each country, you can use, so the directive says for static data, so planned data, data that do not change very often, you need an exchange format called NETEX. for the dynamic public transport data exchanges, is recommended the standard called SERI. Both standards are based on one single conceptual reference model, which is called transmodal and which is a European norm. So, we have said just before that other standards than NetEx are possible. So the problem statement is the following. What are the overlaps and the links between all these standards? So what are the options for the member states when addressing requirements of the 2 directives or even 3 directives, as there is the priority action A, priority action B, and even other ones? So this picture shall figure out the overlaps, that they are overlaps. On the left-hand side, this blue box means MMTIS data categories. The priority action A has provided a list of data, they call data categories, so data information types that are required to be published. And these data categories are covered by several standards. In order to clarify this situation, as already Francesco said, there is a project called Project Team Inspire MMTIS, bringing together 6 experts for the 6 specifications: Inspire, Transmodal, NetEx, TAP-TSI, so for rail, IATA for air, and DATEX2 for road, and Transmodal and NetEx, particularly oriented towards public transport, and of course, Inspire experts. And you will hear after my presentation, the specific presentation of Giacomo, which is the Inspire expert, and will clarify in more detail what is being done. So the timeline is January. Starting this January 2018, and the project is going to end March 2019. What are we doing? Well, first of all, we are considering the differences in scope of the different standards. Well, a very small example, there are, for instance, transport network published by Inspire, and people who do not analyze exactly what the scope is of Transmodal NetEx say, okay, but we also have transport networks, so there is an overlap. Well, our studies shows that the scope of these publications, of this data, is not quite the same. So we are identifying the differences and similarities, and we are now describing the method for handling the overlaps and linking the different standards wherever possible. We are also consulting with ITS and Inspire stakeholders in seminars. We are going to illustrate that method by specified use cases. And then by March, we will have a last meeting providing the full list of recommendations and getting hopefully some feedback on this. So first of all, if you read that priority action A, if you would see that the data categories are only very unprecisely mentioned. For instance, we have the data category like access nodes or route lines topology or address identifiers. What this exactly means was our first task. We should find a common language and see what this exactly means, giving a first definition. But not only that, of course, the second point was having chosen the semantics of that data category to describe the underlying data model. And then we have proceeded to a comparison of the data models in the different standards to determine whether they were or not overlaps. And now the following questions, once an overlap is found, that we are asking ourselves is what exactly to recommend? To whom? To the data providers to avoid overlaps, or to users? So, and which users do we focus? So this is the work. You will see in this small image that this process of comparison data models is not so easy. It happened in several steps. The first step was to compare Inspire to Transmodal. In step 2 was to bring together also other models like TAP-TSI, so the model for rail, the model for road, DATEX2, and the IATA specifications, and to see whether there was an overlap. And we are now, and also there were some overlaps, individual overlaps, for instance, between DATEX and NetEx, between IATA and Inspire, so several combinations. So therefore, this process is a long process and detailed. A first result of that was a very first draft. So we made a table with on the left-hand side you had the data categories. Level 1 means these data categories have to be published by the 1st of December 2019, but every year there are 20 in whole. There are 20 data categories in this as regards the static spatial data, and so these data categories are on the left, and on the right you see the different standards, and the crosses say, okay, here this standard publishes something about this data category. So, but this is not precise enough. So we have introduced the concept of a reference or contributing standard or specification. So we have produced a sort of, among us, a definition. The reference standard is a specification of which the scope covers a particular data category in most comprehensive way. And the other standards are contributing standards of that data category. So more precisely, the scope of a reference standard is such that the standard is specifically designed to publish data for a particular data category D. And the scope of a contributing standard is such that this standard only refers to or uses the data category D to better describe other concepts. So a simple example. NetEx is the reference standard for the access nodes. So access nodes are in fact stop places. And this standard uses addresses of these places. So it's a contributing standard for the addresses. Addresses will never be published as standalone information through an access node, but only in combination with other data. And Inspire is considered as the reference standard for the postal addresses, because these will be published as standalone data sets. So we have been able to produce a more precise qualification of these overlaps, saying which standard we consider, we recommend, or consider as being the reference. So you see, for instance, as regards INSPIRE, we consider that address identifiers, topographic places, points of interest, this information should rely on what is published by INSPIRE. So what next? So we have to finalize an agreement as within our small group. But it's, even if we are 6, the agreement is not easy because we are very deeply involved experts in these specifications, and so we are we have a lot of discussions as regards the qualification of the specifications for all the 20 spatial static data categories. Priority action A, I didn't say that. There are also other data categories which are time-related, like timetables and runtimes and so on, which are useful for, of course, for journey planning, but we are considering this type of information, so spatial static data categories. According to European regulations, data providers are free to provide data so that data sets overlap. This is allowed, and this, I think, will happen. So we have really to consider what type of recommendation is most useful. On one hand, we think that overlaps have to be avoided to spare, the data providers should not publish data twice. But on the other hand, as the situation is as is, we are providing mappings between standards where the overlaps are considered by us. And we will provide some guidance how to manage this, how to use these mapping tables. An example of, here once more a picture, the blue box is the national access, shall represent the national access point. And you see at the bottom the data providers that provide data using each its own data model, data format to publish this data. And on the other hand, on the other side, you have users of this data. So what may happen is that if you see the blue line, people who are providing stop place data with addresses through the NetX standard. On the other side, we say that addresses are, the reference for the addresses is INSPIRE. So what they want to get is the stop places with the green address, with the INSPIRE address. So we are providing a mapping between the different address formats and formulating these recommendations. So to conclude, the project is challenging because the specifications are complex and a result of many years of investigations. INSPIRE is a long process, but for instance, I must say Transmol, of which I was the initiator in the 90s, it's also, you can count, the first version was published in 1994, and so it's also a long process. and there is a lot of material to investigate. The main objective is to help in understanding what is in the scope of different specifications, what data categories are going to be published, by which specification, what are exactly the overlaps, what's the preferred recommended process to handle the overlaps, and how to take advantage of the INSPIRE dataset publication in the context of the MMTIS directive, because INSPIRE is the predecessor of that directive. So next stakeholder meeting, so for consultation and information is planned to take place on the 20th of November this year in Brussels. Thank you.
Good morning. My name is Christopher Dodson, representing IATA. I wanted to give a quick overview of the rationale and the context of IATA's participation in the project. So IATA represents the interests of 290 airlines, which is 82% of total air traffic. The pace of change in this domain is extremely fast now. So IATA has been reacting to keep pace, and industry standards for setting governance is changing. And as you can see from this first slide, the organization within IATA is changing as of November the 1st this year. So we're moving from committees that were looking at tickets, reservations, and largely writing resolutions. There were a lot of words. So to something that's much more business focused, defining business requirements, publishing implementation guides, and providing tools. There's now an online portal for collaboration. So this is going to enable expert groups to collaborate across the domains much more efficiently. And that's why we see this organization in this first slide, which starts with planning, pre-flight, the shopping, then the traveling itself, and then the payment for the flight, and all the services. And then an architecture and technology strategy board, which is the area that I'm working with, and the area that's contributing to the project. So IATA is developing an airline industry model, a data model. So a data model much like other data models. So an integrated model with defined structure and behavior, business processes, information models, message models, and a consistent methodology across all projects. There's quite a bit of automation, and generation of message specifications can be done from the model itself. And it's going to be used for all passenger standards, any project that's being developed, and in developing new standards or aligning existing ones. And it is now public facing. So in the past, the models, the standards have been proprietary. This is now no longer. So the web address is there on the screen. It's using Enterprise Architect, like a lot of other people, a lot of other models. And there's a question email for anybody interested in questions. And the other thing that is a big push now within IATA is open APIs. There's a document which is available, the web address for the documents on the screen. APIs, as we know, is a way of sharing data. It's effective, promotes an open ecosystem. And IATA had been tasked to promote the concept and to make it a normal way of sharing data across the industry. So the directives were given in 2017, So the work on developing the standards and best practices has been going on, and there have been some recent successes, shall we say. But all industry APIs will leverage the airline industry data model, the IATA. So if we look at APIs that are provided by airlines today, the ones that interest the project that we're addressing today, probably flight schedules and flight status. But you can see that there are some open APIs and there are some that are, should we say, closed or proprietary or non-standard. And that's now. And by 2020, the plan is for a lot more implementations. This is based on a survey of 54 airlines this summer. So you can see that the uptake of these APIs is very good. So this is the concept. We've got data providers at the top of this slide and data consumers at the bottom. The IATA API in the middle. So these are travel communications APIs with data relevant to the traveling public, including use cases such as flight schedule, flight status, which then combines to be basic flight information. And those APIs will be consumed by various consumers that will also have their own APIs that will mix it and dice it and slice it to provide solutions for the traveling public. So where does this all fit in with what we're doing? Airlines live in an extremely competitive environment. You see situations where the money is spent once and then things remain as they were for a very long time. So things are driven for commercial reasons. So there are legacy standards and bespoke messaging options in place all over. And if we just looked, for example, at how schedules get delivered to airports, there's a complete mix of the way this is done. Some airports get their schedules direct from airlines, some get them from slot coordinators, and some get them from commercial consolidators. So there's no consistency, there's no standards, it's all done in a very different way. So that's not what we want. It's not what we want. So there are new business drivers coming along to rationalize all of this, including the project that we're addressing today, which will leverage AIDM, the data model, generate standards based on these standing messaging specifications. And OpenAPI is going to be the delivery method, or is the delivery method. And IATA is going to deliver part of the Inspire MMTIS requirements, which is why it's extremely important to map the data models that are in scope and identify the overlaps, which then feed into the use cases and provide the recommendations. So IATA is completely behind the project, its methodology and its rationale. And I hope that explains where we are. Thank you very much indeed.
Thank you, Francesco, for the introduction, and I hope to always keep high the trust on me about the Inspire, but as we are seeing, a lot of dynamics are going on. So, as Kasia was telling at the beginning of his presentation, I'm one of the experts bringing the expertise about Inspire in this multimodal travel information services study that we are running. So the outline of my presentation, just a small overview of the policy context in which I will try to share with you the idea that Inspire could contribute a bit more than what is really stated in the delegated acts, in the regulations. Then we will see how, going into the details of the different data categories, this contribution can come, mainly from the transport network, but also from other inspired themes, as we will see. Going forward, in terms of sharing and reusing experience in the overall national access point setup and operation, and then sharing with you some conclusions. So this is what the delegated act is requiring in the Article 4. They say that for, as Kasia was mentioning before, for the spatial network, the requirements defined in Article 7 of the INSPIRE directive. So for me, this is, I would like to share with you, this is an important achievement of INSPIRE, because INSPIRE is mentioned in another domain piece of legislation, which is something that all are belonging to the INSPIRE family are aiming at, I think, independently if we are providers or users, and this is a very important achievement that we hope can be reused in other domains, in other policy areas. So in here there is a specific requirement that for the so-called spatial network, INSPIRE is the reference. But then, apart from the other possibilities that we will see coming from other INSPIRE themes, I think there is this important sub-clause in the Article 3, national access points, because it says, national access points shall provide discovery services to users, for example, services allowing for the search of the requested data using the contents of the corresponding metadata and displaying such contents. Here, INSPIRE is not mentioned at all, but I think that you all agree with me that INSPIRE can play a key role in this aspect. And here is some, let's say, visionary horizon in front of us, because they say that APIs that provide access to static travel and traffic data listed in the annex via the national access point should be publicly accessible, allowing users and end users to register to obtain access. So I think currently there is another presentation on open SDI for a government. We see that a possible direction to exploit INSPIRE further is through this API to improve the use of the data. So there is some hook here also in this domain. So having provided these hooks from the legislation, in this picture we can schematize the role of INSPIRE. So in blue are the mandatory ones, let's say. So in terms of data category definition, INSPIRE is the reference standard for spatial networks. But in green, we have identified other possible contributions coming from INSPIRE. In terms of data category definition, there are possible contributions coming for other data categories like addresses, points of interest, we will see in a while. And then in general, for the organizational aspects, for the national access point setup, INSPIRE can be a possible source of data to be made accessible through the NAPs in order to apply once more the only once principle, and then possible source of recommendations for NAP setup in terms of metadata, all the components, network services, validation, registry, persistent identifiers, geoportal, and so on. So INSPIRE can play a big role here. These are the data categories we focused on in the, you see here some similarity with the INSPIRE roadmap. The data categories are listed in 3 clusters, and the first one depending on the level of service. So data here are, these data categories have been identified to serve some services to be built by the transport operators. The first deadline is the end of 2019. These are the data categories. And our study started just from this plain text with this more than a definition, because if we go in the definition of INSPIRE, of the data teams, of the models, there are broad and wider definitions. Here it's just a sort of small definition, just a label, I would say, and the title for the data categories. So starting from that, for the mandatory requirements for the spatial network and the other possible contributions, we identified which are the INSPIRE data teams that can contribute. So, apart from transport network, which is a mandatory one, we saw that also addresses and administrative unit and geographical names of Annex 1 can play a role, but not only, because for Annex 3, buildings and governmental services, for the utility and governmental services, data team can play a role in the definition of the of points of interest data category. In terms of spatial network, I'm just scrolling here some pictures taken from the data specifications, in which are underlined not only the you know better than me, the structure of the concepts, the basic concepts of the transport network, which inherits concept from the generic network model, in which we see the sequence of nodal links to define more complex infrastructure, physical infrastructures. And then for the different modes here, there are some, also in INSPIRE, there is some view how to use the data for multimodal transport, because here you see the picture, the road, the railway nodes, that even though we learned from the transmodal that more specific definitions are not so easily to be found in INSPIRE. So that's why INSPIRE for some teams is just contributing, and at the end of a deeper analysis maybe cannot contribute at all. But just to underline that even here in the INSPIRE data specifications, the concept of use the transport network datasets for multimodal transport has been conceived at the beginning of the drafting of the data specification. Other examples for the properties of the road network, for the rail, and for the water transport network, and also for the air ones, because for here you see that there is for instance a link between IATA and INSPIRE, because for the feature type aerodrome node, which is a subtype of transport nodes in the air schema, we have two attributes, and one of them is IATA code. We are still maybe far from the full, let's say, linked approach, because it's just a character string, it's not a code list taken from IATA, but some principles are already there. But now let's look at how other INSPIRE themes can contribute. And I think very interesting is the study that we are currently doing for the points of interest, because for addresses we saw that postal address, which is one of the sub data categories of address identifiers, the postal address are very well matched by addresses of INSPIRE, and that for INSPIRE we propose that even though it is not written in the there's not a subclause D after the C saying that for spatial networks Article 7 of INSPIRE is the reference, but probably even though there is not any specific legal requirements that addresses are a reference, the reference standard, we are demonstrating that why not to consider the European harmonized datasets of addresses, of course, once available according to all the requirements of INSPIRE. Also topographic places, there are geographical names that can contribute a lot. But in terms of point of interest, we identified these three data teams: utility and governmental services, building, and also protected sites. Just to share with you some of our thoughts for this is a snapshot of the application schema of governmental services of the US team. And for the feature type governmental service, we have one attribute which is called service type, whose data type is a code list, service type value, and we already have in the INSPIRE the service type value code list containing 56 values with 3 hierarchy levels, which are extensible with narrower values. So we know that in many applications, point of interest have to be, could be better to classify them in terms of main categories, subcategories, but here INSPIRE can, for the governmental services, can be a good source of information. In terms of buildings, we have, let's say, 3 important aspects to mention. The building nature attribute, the current use attribute, and also the name is important here. Why? Because for the building nature, even for building nature, there is a code list containing 20 values with 1 hierarchy level, extensible, but extensible with values at any level. For here, I would like to mention the importance to not to forget the name here, because just to make an example, here one of the values of this code list is a castle. A castle can be a point of interest in a destination of a multimodal journey, but in this case, if we don't, because here the name is an optional voidable attribute. So it's important to put the name also of the castle, the proper noun, otherwise we are not interested just to find castle, but we are interested to find castle A or castle B and so on. Regarding the current use value code list, we have 13 values with 3 hierarchy levels, extensible with narrower values also in this case. So it's here there are not, we have to be, in this case for points of interest is one of the data categories required by the MMTIS. We can imagine all of us using our car navigators when we want to set our journey. We want from A to B, we want A is our home, B can be a restaurant serving Japanese food, for instance, which is a very typical use case. But we have to take care that in Inspire it's very difficult to find this kind of information, because unless we want to embark in a commitment to extend with nanover values some of the parent values which can bring to a definition of restaurant serving Japanese food, it's something that we should think about. But in terms of public services, hospitals, schools, and so on, Inspire is already there, just to mention. In terms of implementation experience reusable as additional support to national access point setup and operation, we have identified these 4 that we hope that the customer DG Move can duly consider. Setup and operation, for instance, of an EU geoportal which harvests the national access point catalogs and provides a single access point to national datasets. We are learning in this conference now the new version of the Inspire geoportal. Imagine in your mind this national access point which have to be set up by member states, serving the data of all the data categories useful for the transport operators. They are in this delegated act, they are not providing any specific recommendation or requirement how to set this up. So why not reusing Inspire principles, which are so also in other discussions that we are having with member states, they are asking why not reusing Inspire as much as possible, because the systems are already there and so on. Set up and operation of a code list registry to support the harmonization of vocabularies, which is a very important recommendation to consider. Also of a validation service allowing member states to self-validate their datasets, metadata, network services. For instance, in Inspire we have, in each data specification, we have the ATS, the abstract test suites. Then they are going to be made available executable test suites to check and validate. Right now, in the regulation, there is some generic recommendation to leave member states to self-validate their datasets, but without providing any specific roadmap to do that. So Inspire again can play a key role there, as the definition of rules for persistent identifiers management. Going to the conclusion. So I think that we all can agree that Inspire can play a key role as a reference standard for some data categories. Inspire principles and experience can be reused as additional support to national access point setup and operation, but most importantly, I think here that from few examples that I commented, Inspire implementers, mainly data providers, have to pay attention in order to make their datasets really usable within the MMTIS context. The example of providing optional avoidable attributes with their value is really important to make data usable. This is a general recommendation, not applicable only in this case, but more in general, but even in this case is more important. And just to give, last slide, to give an example about this last point, for transport network, which is one of the legally the reference standard, Inspire implementers have to pay attention to make their data serving the needs of MMTIS, because in the piece of the schema of transport network, we see that in order to guarantee the topology of the physical infrastructure, the start and end node of each link are optional attributes. So you can imagine that if you miss this information, you can't guarantee any application to navigate through the physical infrastructure. So it's very important that due care is paid in implementing Inspire. We are saying we want to export Inspire in other domains, that's fine, but we need to be sure that we serve properly all the needs. I concluded my presentation. If you have any question, we are at your disposal. Thank you.
Thank you, Francesco. So very heartily welcome this morning. As Francesco mentioned, I'm affiliated to TomTom. But I also wearing a virtual hat from Etico. I'm the platform president of TNITS, and that's what I'm going to talk about. So first I'm going to set the scene, what TNITS is about, and then I will elaborate on the new project which is running now, and which is going to provide for a number of services that are sharing changes of road data from road authorities to map makers, private industry, data users in general. So regarding the platform, TNITS has a mission and a vision, of course. So the vision is to bring fresher map data to ITS transportation services. That's the general aim we have in mind. And the way to do that is to facilitate and foster the exchange between road authorities and data users on changes of road data. So this is a bit complementary to the concept of Inspire, is that we in this platform focused specifically to changes. So as you know, it's very important to have the maps up to date in the ITS systems, and maps are very important in these systems, and they will continue to be very important in all kinds of systems that will drive automated driving, for example. So it's really important that we have the basis right, and the base is going to serve to put all kind of dynamic information on top of that, of course. But to get the basis right, we need access. So map makers need access to sources which can be trusted, and so that's why we are looking at road authorities to provide those data in a standardized way, applying a common interface. So here is a more thematically where TNITS is situated. So it's defining not only the technical interface between services running at the road authority side and those at map makers or data user side, but it's also stimulating the knowledge, so not only technical aspects, but also things that road authorities should know, service level agreements, open data, or data licenses in general. Those things are discussed in the platform and agreed upon with as many European road authorities as possible. So the platform has a number of members representing different stakeholders, and it's really important that in this case, the private industry is really pushing all the stakeholders together with guidance by the Commission and the active involvement of quite a number of member states to make this happen. So there's really a demand from the industry. It's not simple demonstration use cases. I will show later that the industry is actually reusing significant amount of that information in the database. I'll come to that. So we have a number of prospect countries. We have in France, we have IGN that mentioned that they will sign up to this platform. We also have other countries like Netherlands and we got the third one. So we have three prospect partners this year. There are a number of associations which advise the platform, like ETSC and some ITS organizations. This is a bit the storyline of TNITS. So the platform itself was founded in 2013. It continued on some earlier research, FP7 or FP6 even, research projects that happened. Along the next years, we conducted a number of pilot projects which actually have led to operational service in mainly the Nordic countries. And the transplantation pilot was very important for that path to set the path towards operational systems across Europe. And so we had the transportation pilot, we had another pilot that was concluded end last year, which led to a number of pilot services in Ireland, UK, in Flanders, in Finland and in France. Quite an important step that was taken last year is the fact that there is a technical committee from CEN that's going to publish the TNITS specification. That actually next month we expect that this publication will become effective. So from next month on we will have the official CEN technical specification in place to support further deployment. It's often before we had this CEN stamp, there was always a question from the different member states, from the different road authorities, like, are we looking at the right standards and should we not think of other ways to implement services running this data exchange? I should have said it in my introduction, but I want to emphasize 4 important points that actually celebrate 2018. So one of them is the TNITS Go project that kicked off, and I will talk about that a bit later. So what are we focusing on the platform? One part is the technical specification. I mentioned that. So in October we will have that technical specification in place, and we also do implementation support. So we advise as a platform road authorities that wishes to set up services and define the APIs so that they can publish changes of road data as speed limits, changes of traffic sign, that type of information as a service. We have a number of working groups. I will not go into details, but they are led by different stakeholders, and you see a good representation both of industry and government organizations. So location referencing work group is led by TomTom. The work group on specification and standardization is led by the Norwegian Public Road Administration. Implementation support is led by the Finnish Transportation Agency, and mapping company here is leading the tools work group. I'm not going to go into detail. I typically pick out the top row. This gives an overview of the status of the TNITS services today. So if we pick out Sweden on the top row, the provider is STA, that's the Swedish Transport Administration. The TNITS service is operational. Data, so changes of road data are shared for all roads on the Swedish road network. The key map attributes which are shared are speed limits and traffic restrictions and road information, so road names, for example. Sweden, in their service, support a number of location referencing methods like OpenLR, the Inspire linear referencing method, and GML. So if you go to their service, you would see in an XML description, though, for each update that they publish, these 3 location references. The data license is mentioned. It's open data, and it's open data in a with terms and conditions which allow commercial reuse. And I have to emphasize that not all open data is data that can be reused by private companies. There might be share-alike restrictions to the data which actually limit the reuse, despite the fact that it's officially open data. So if you look at a number of other services, you see that there's a mixed view. Some of them, especially the Nordics, they publish the data as open data. And this is a mindset that if they share the data, so government data, and it's picked up by private industry, it's going to serve their citizens in the best possible way. It's one philosophy, but it's not shared across Europe, and we have to work on that vision. On the last column, you would see the update frequency. So Norway, Sweden, Finland, not Finland. I think nowadays it's more or less the case. So either they share on a daily basis, they share the changes they have on their road network. That does not, of course, mean that it's really a live change that flows through the system in one day. It's actually referring that once it's in their system and they are ready to publish it, they can publish that. They do that in one day. So there's still some work in the data collection part of their activities, but on a technical level, typically in 1 day to weekly, they share the information with all the data users. Typically, if you look at the throughput cycle at the leading mapping companies, you would see that nowadays it's like on 1 week time is necessary for the input until the data is processed and made available for the for end users. So it's still 1 week. Both here and TomTom are working very hard to bring that down to 1 day. Why is that so slow? Sometimes it's asked, like 1 week is still a long time, but there are a lot of quality processes in place to double check the information. And with in this case, when the data is coming from road authorities, the data is flagged as coming from a trusted user and is ingested in a data engine to be handled much more quickly than if it's community input, where the quality level is questionable, or could be questionable. So where are we now? I showed the services for the status for 2018. To continue, like the horizon for the next 4 to 6 years, we will extend the technical specification to support new road features and attributes, especially for autonomous driving, multimodal use cases, and also logistics. So we are talking to different stakeholders there to make that happen. So it's not only about the specification, it is also ensuring that road authorities are going to publish information and in this agreed upon format. If we look at this example for autonomous driving, there's need for alignment on, for example, access restrictions. So in a foreseeable future, we expect that some roads, some lanes might be open for autonomous driving, for different level of autonomous driving, you know, these SAE levels. A way how road authorities could manage this access is via TNITS. And this would be done in a static way, and we are talking to TISA to realize that on a dynamic way as well. So the baseline would come from TNITS, the dynamic changes for access for autonomous vehicles would come from TISA feeds. I mentioned that before, so the alignment with other standardization platforms, the Open Autodrive forum is important in our community, DATEX2 we heard about, and TISA, of course. I mentioned before the importance of the reuse by the public sector, and this is a slide that was provided by here. It shows a dashboard showing the number of changes of road data that are shared by, in this case, the Nordic road authorities. You have a baseline of a few hundred changes on a weekly basis, and you see some peaks when there are some programs, for example, that reflect a change of a speed limit from 90 to 70 on national roads, something like that. That happens in some countries, and then there's of course a peak in data that is shared with data users. It's too small to see, but all the green ones are changes in speed limits, and all the blue ones are changes in the road name. And it says, early this year we have achieved the 1 millionth update since the start in, I would say, 2016 of the operational services of TNITS. This is a movie that's made available by TomTom. It shows the changes of speed limit over 1.5 year period in the Stockholm area. So typically, when asked like how much does speed limits change over a year, it's typically 10% on a I would say a national basis, and this type of information seems to support that message. I mean, from a distance you would see that a quarter of the roads, maybe a bit less, have actually changed speed limit in that time. So it is important that this data is shared and reused by data users, or map makers in this case. Then a few words on the project that was launched earlier this year. So this brings together a new set of stakeholders, joining with a few countries that have already experience and they have already a service up and running, or a pilot service that they have realized. So the ambition is that we set up 9 new services in 9 member states, of course, and the newcomers are Cyprus, Greece, Portugal, Spain, Slovenia, Hungary. We have the Baltics as well, 2 countries in the Baltics. I think that's more or less it. So it also joins the TomTom and here as map makers. Ertico is doing the coordination. The idea is that the mature services or the operators, road operators and the road administration from the mature services, they extend their offering. So that requires, of course, the updating of the specification. What is also very important is this time we will also implement a feedback mechanism between the users of the data and the providers. So in the past it was more on a very minimalistic way how this feedback was realized. So the data users were able to provide a kind of a digital thank you for your data message, but now it's going to be much more elaborate. As an example, the success rate of the integration of the data that is provided will be fed back. If there are issues, it will point to the root cause of the issue, like an error in the location reference decoding, things like that. And that is then going to help the road authorities and the road administrations to improve the service, or to learn why there is an issue with the information. There could be very different sources for that. So the project will run for 4 years. Next to these more mature countries, we will have in these 9 new member states, so the basic pilot services. We target to share speed limits and changes in traffic signs. So these are the most important attributes on the roads that are going to be shared. So the key takeaways, and these are the important points for 2018. So we will have the technical specification in October. We reached the fifth year for the platform, so we had a celebration and a cake in June for that. We have this TNITS Go deployment activity that's kicked off, and as I mentioned before, we have this 1 millionth update that was obtained. So with that, I thank you for your attention. So the question was on the special license situation for a number of countries in Europe. Yes, there are parties, I would say, that have in their mission to either be self-sufficient or search for extra income to support their activities. And that probably translates into the license condition to which they share that data. And we have the situation with IGN Historic, and Ordnance Survey. There are indications that this is changing and that they might be more opening up their data, but this will probably be a process that will take a couple of years to happen. I have a colleague here. He can maybe give some input on the Ordnance Survey situation, offline or after the talk.
Thank you very much for your presentation. My name is Antonio Arozarena from the National Mapping Agency in Spain, Instituto Geográfico Nacional. Well, that you know, and probably all people know very well, the transportation network is very important in the spatial reference data for the Copernicus services. Mm-hmm. Last week in Brussels, the European Commission, especially the Commission and the European Environmental Agency, decide not use the transportation network for the member states. They use an open tender for the private company. In this sense, probably the most important company is the OpenStreetMap. Mm-hmm. Do you have any contact with the European Environmental Agency in order to facilitate, because your presentation is a clear cooperation between member states and a private company, but do you have any contact with the European Environmental Agency in order to facilitate the transportation network for the Copernicus services?
The answer is very simple. No, at this moment there are not, but I will definitely look into that. I'm very much interested to learn what the visions are there, and we have, from experience and historically, we have seen that the optimal way forward is for road administrations to share data based on their own national mapping system, and that's related because then they own the IP. If they go out and look for third-party maps, there is often a IP issue related to sharing information, and that is most of that is solved if data is shared from the national mapping agencies, because then they own the IP. But very good suggestion. I will look into that.
Thank you for this presentation. Markus Jobst, NMC in Austria. You mentioned the road authorities as providers for the data set and transport networks. So we know that road authorities cover highways, expressways, main roads. How do you deal with those municipality roads that are maintained by a lot of municipalities?
Good question. It is a challenge, and we see that the different countries in Europe, different member states, are tackling this topic in a different way. Especially in the Nordics, and typically the smaller the country they are, the more overseeable the situation is, and the more they stimulate municipalities to share data of speed limits, for example, with a more on a federal level. So they can do the stimulation, they can offer tools, they can offer guidance, but often there's no legal mandate to impose that these changes are shared. However, we do see a lot of activity and awareness and willingness from municipalities, from cities to start sharing the data, or even already using the TNITS standard in between organizations themselves. And as you know, the situation is very complex, and we will have to face that. In France, for example, there are, I don't know, 36,000 municipalities, and there's no legal mandate that you have to share the changes of road data on their particular own road network that they own and operate. It is a challenge, but we see that there is progress in that, and especially from the Nordics, they're very active to get all these components in a data chain ready.
Okay, thank you very much. Hello, good morning, everybody. I'm Alicia González from National Geographic Institute of Spain. And I would like to show you this presentation, the challenge of update, Inspire Compliant Transport Network Database. So in this short presentation time, I would like to focus in two main points. The first one is a description of the main characteristics of this database, and second one, how the IATA Spain is facing the challenge of its update. So let's start. From 2015 to 2017, IATA Spain carried out the production of the first version of the Geographical Reference Information on Transport Network Database under the following main requirement: to be Inspire compliant and to be created from official data reuse. So, this database is a 3D seamless transport network database all over Spain. As it is Inspire compliant from a data model point of view, it contains 5 transport modes. It contains roads, distinguishing the different kind of roads, and also the kilometer points are linked to it. And as it is seamless network, it also contains more detailed information inside the urban areas, like street roads and building number, even though that this information, as we saw before, could be more proper for addresses, but very linked to transport data also. So we contain also bicycle roads, and in the countryside and in the rural areas, we also have integrated the information regarding paths and ways, and also we have roads. Regarding railway transport network, we have integrated information about the railway lines and their corresponding kilometer points, and also the railway station, just together with different railway links. In relation with waterway, the information we have harmonized and integrated is the ferry crossing waterway lines, and also all the information of the infrastructures of the ports all over Spain. Regarding our transport network, the information we have, we deal with is related to the infrastructure, all kind of aerodromes and heliports. Finally, even though we have few data about cable transport network, the available data when the database was created were also integrated inside. So one of the most important characteristics of this database is that it contains the intermodal connections among the 5 transport modes. And they have been implemented by linking the network nodes, this kind of point that you can see. Finally, the infrastructure, I mean the ports, the railway station, this kind of infrastructures, everyone is linked to the network they belong to, and everyone has been defined by 3 kind of feature types: area, point, and node. So this information is also Inspire compliant from a web service point of view, and we have developed the different services, the mandatory services, just to locate, to visualize, and to download the data. So yes, some images to illustrate it. Here you can see an example. Oh, no, you can see. Well, at the top is the answer to the WMS request, and you compare the different per trial, the national versus INSPIRE per trial. The second part is an example of the railway station. Here I invite you to visit this website when you can use this viewer to compare the different per trials. And more examples, at the top you can see the different representation of the airports, and finally is an example of Bilbao port. So, regarding downloaded INSPIRE compliance services, it also is working, and you have the URL, and you can see the different transfer feature type that you can download and the different properties. In addition, all this information are also available by downloading shape files in the official downloaded website of the IGN Spain. Well, according to the second main requirement, this information has been created by gathering and integrating official data. So, at the starting point, I can't sign, sorry. Well, at the starting point, the database were populated with information from the National Geographic Institute, from this existing data in the traditional cartography products. But this database were supplemented with official data information from the main providers in the transport network scope. So we have harmonized and integrate different data sets from cadastre or from different data sets of the Public Works Ministry. In addition, data from the regional mapping agencies were also integrated into the database. Moreover, the region of Valencia became as co-producer of the data inside the region. So once the database was finished last year, it became somehow in a data source for the original providers, as it contained value-added data like intermodal connections or different kind of representation of the infrastructure. And this information is very appreciated and interesting for the original providers. And in this sense, I would like to focus in two use cases arisen inside the Public Works Ministry. The first one is just the traffic map of the main national roads. It's a very simple example, but they are using now as a reference the answer for the WMS services created on our database. And the second one goes further, and the ministry is working just to use our data as the spatial reference data to link the national mobility information that the ministry has to report to the European Commission inside of the European Transport Network scope. So for us, this is a very good use case and a very gratifying use case because we can touch the utility of using INSPIRE compliant data. So where we are? Well, now we are facing the huge challenge is how can we update this database? And the first answer is the methodology is not simple. We have to consider different kind of action lines, and here I'm going to mention the most important. We are considering massive update process, and in this case, we are implementing automatic processes to integrate update official data. This is the most relevant example is with information from the INSPIRE compliant WFS service of the cadastre. On the other hand, we are also working on the selective update process. And in this case, we are developing processes based on the changes automatic detection between our data and vector and raster reference data sets. Regarding vector data sets, we have done a pilot, and here we compare our data with OpenStreetMap data. So far, we are only focused on road and data from a specific period of time. And the idea is just to look for the differences and analyze that. And if is just in case that we have to update, then we request the official data. We don't update our data with OSM data, but it is a useful tool just to detect or to warning about area to be reviewed. In relation with the raster dataset, what we are done is also another pilot, and here we compare two orthophotos from the same area but taken in different dates, and by using artificial intelligence and deep learning technology, we detect the difference in transport elements. We think it could be very useful for secondary roads, because for the main infrastructure, of course, we know when they are building and it's more easy just to detect the change. But for secondary roads or maybe for ways in the countryside, it could be a very interesting solution. So we are now working on this all action lines. So just to finish, two main conclusions. The first one has arisen in another presentation during days in the conference, but it's true, it's really true. Being Spire compliant doesn't imply near production, but it's a great opportunity to be more efficient. That's true. And the second one is more related to this theme, as from our point of view, a useful transport network database must be an alive database. So from our point of view, we have to invest, we have to develop methodologies based on selective detection changes. Thank you very much.